All right. So in our lecture two, we want to look at some technical estimating questions. Our question one says that a plot of size 3 hectares is to be cleared, excavated, compacted, and then ordered. I, given that the depth of excavation is 250 mm, determine the volume of excavation. If the plant used in the clearance has an output of 600 meters squared per day, determine the duration. Given that the high rate of the plant is uh, 3,000 per day, determine the unit cost. So it continues like that up to the X that says that if the contractor wants to finish the clearance in 5 days, what are his options? Okay, so I'm sure we've met this kind of questions before. Yeah, so this is what we are going to be solving and see how we are going to be able to just cover something. So let's just move to a fresh page and then begin to solve this one after the other. All right. So we can start from here. So this is our question. Okay. This is our question. This is the question we're having over here. And I'm going to be solving each and everything we need to do over here too. So our question one says that a plot of size 3 hectares is to be cleared, excavated, compacted, and then ordered. Given that the depth of excavation is 250 mm, determine the volume of excavation. So let's try to put down our given and then see if we can continue from our I. Okay. So our given. Okay. So we are having a plot of size 3 hectares is to be cleared. So let's say that the total quantity or the area, okay, is 3 hectares. So our total quantity, our total quantity is equal to 3 hectares. Okay, good. And then also, they say our depth of excavation is 250 mm. Now we are supposed to determine the volume of excavation. So now our depth is equal to 250 mm. All these values, we have to convert them. You see, okay. So, but you have to know that 1 hectares, okay, 1 HA is equal to 10,000 meters squared. Okay, this is something you have to jot down. You already know, so I don't have to talk plenty. Yes, 1 HA is equal to 10,000 hectares. Okay, so at the end of the day, this our 3 HA, what is it going to be equal to at the end of the day? You realize that it's going to now be equal to 30,000. Okay, so this is because if we are saying that 1 HA, which is a constant, is equal to this, then what is going to happen? Then our 3 HA is equal to S. So if we do cross multiplication, realize that 3, 3 times your 10,000 meter squared. This is meter squared. Okay. So at the end of the day, if you multiply 3 times 10,000, you are going to get 30,000. Okay. So after the conversion, you are getting 30,000 meter squared. You see. Okay. From there, what are we supposed to do next? The next thing we are supposed to know that we are supposed to convert also the 250 mm into what? Meters. Okay. Yes. Because we said that we said 10,000. Okay. We said 1,000. 1,000 mm also is equal to what? 1 meter. So the 250 mm, what is going to happen? Is also is equal to x in this state. Okay, so if you consider this one too, you realize that at the end of the day, uh, you have to divide 250. X is going to now become x is equal to 250 all over what? 1,000. Yes. So if you do this at the end of the day, zero cancels zero, and then these two zeros is going to go in this order. So you're now going to be left with 0.25. You see, 0.25 meter. So that is the depth of excavation. That is the depth of the excavation after what our convention. So this is here is also now going to become, let's say, 0.25. You see, exactly. Uh-huh. So from here, we can now go back to our question, and our question says that a plot of size 3 hectares is to be cleared, excavated, compacted, and then hoarded. Given that the depth of excavation is 250 mm, determine the volume of excavation. So we can now start from our I, you see. So let's just move straight to our solution since the question is a straightforward question. Okay, so in this case, our I, we can start from our I, and then our I say we should determine the volume of excavation. Okay, so the I determine the volume of excavation. So that implies that our volume of excavation is our volume of excavation. Uh-huh. Volume of excavation. So our volume of excavation, how do we calculate for that? That is going to become V is equal to area times depth. Okay. The total quantity is the same as the area. Take note. The total quantity is the same as the area. And these are some list of formulas I have over here. These are some list of formulas I have over here. So don't get confused. If you meet, let's say, if you meet meter squared, then you know that at the end of the day, you have to make your reference to this. If you meet meter cube, you know that you have to make reference to this. Okay, but in this case, we met meter squared, this. So we are making reference to this. So our total quantity is the same as our what? Area. Exactly. Exactly. Okay. Uh-huh. But take note, the one we are doing now is volume of excavation. Since it's volume of excavation, we have to put more emphasis of this one, which is the meter cube. Okay. Yes. So the total quantity is the same as the volume of excavation, and the volume of excavation is the same as the area. Okay. Times is the same as the area. The whole of this is the same as area. Okay. Times either the depth or the height. Okay. All giving you the meter cube. uh-huh. So look at what is happening over here. So our total quantity is equal to what? Meter squared. Okay. So the meter squared. Now they say we should calculate for volume of excavation. So our volume of excavation now is going to be equal to what? Area. Okay. Area times depth. Okay. So at the end of the day, what is our answer going to become? We have to multiply the area times the depth. And what is the value of the area? 30 meter squared. So we have to 30,000 meters squared. So we have to put it there, 30,000 meters squared. Okay. Times the depth, 0.25 meters. So at the end of the day, what is our volume of excavation going to be? So let's all multiply it together. 30,000 times 0.25. What are we getting? We are going to get 7,500 meter cube. Okay. Indices, if the bases are the same, for the units, if the bases are the same, you add the exponent. That's why we are getting it to be meter cube. Take note that volume is always what? Calculated in meter cube. Okay. So we are done calculating for our volume of excavation. So let's move back to the next question. So we are done with this. So we take, and then I want to change the color pen for this page. Okay. So we are done with this one. Now let's move to our next one. If the plant used in the clearance has an output of 6,000 meters squared per day, determine the duration. Determine the duration. So we are supposed to determine the duration. The first one we determine the volume of excavation. This time we are supposed to determine the duration. Okay, good. Let's read all the question back. And it says a plot of size 3 hectares is supposed to be cleared, excavated, compacted, and hoarded. Given that the depth of excavation is 250, determine the volume of excavation. We are done calculating now that. And our we are saying that if the plant used in the clearance has an output of 6,000 meters squared per day, determine the duration. It means that it's not human beings that are going to be doing the excavation, but they're going to use equipment, machinery, or plants, okay, to do the excavation. Okay, so that plant has an output. Okay, the whole day it can clear a total area of 600 meters squared, okay, a day. So let's determine the duration. Let's determine the duration. Okay, yes, let's determine the duration. Okay, so from wherever we learned the other day, what did we say is the formula for duration? So the duration is equal to the total quantity over the daily output. Okay, now this is the daily output that has been given to us over here. Take note, always you have to watch the daily output clearly to be sure of the one you are supposed to use in calculation of your hot duration. Okay, so the output is going to help you. Since this one is hot meter squared, it implies that we have to hot use the area but not the volume. Okay, we have to use the area as our total quantity. Good. So let's move. So now we are in II. II says we should calculate the duration. Okay. So now we are calculating for the duration. And in this page, what we are going to be doing is we said our duration is equal to um come here. Let's all come here. This is it. The duration. This is the formula for the duration. And we say the duration is equal to the total quantity over the daily output. So you are saying it can either be in day or days. Okay, because if your answer is 1 day, you can't say it's days. It has to be 1 day. But if it is two or more, you can add the s to it, days. Okay. All right. So total quantity, the total quantity, the total quantity. Okay. So let me just forget and let me just put the symbols there since we already have the formulas over there. Okay, so let's say total quantity over the daily output. Okay, good. So now the duration, we have to just fix in the formulas and we are good to go from whatever we have learned or whatever I told you so far. So now we are saying our duration is going to be equal to the total quantity we are supposed to use in this case is the 30,000 meters squared because of the duration we are having at hand. The duration that was given was what? 600 meters squared. Look, 600 meters squared per day. Okay, yes, per day. So at the end of the day, what is going to happen over here? We have to put the total quantity. If you can't, because at the end of the day, meter squared have to cancel meter squared for you to get your answer in days. Okay, so we are going to put 30,000. meter squared. Okay. So finally, we can say that our duration is equal to uh, this. So let's do some cancellation. This meter squared can take care of this meter squared. And then we can now say that two zeros can also take care of two zeros. So what are we left with? Let's all divide 300 by 6. You realize you're going to get 50. Are we all getting 50? So that implies that our duration is equal to 50 days. Our duration is equal to 50 days. Okay. Okay. So we are done with the second part of the question. Let's go to our um I. So we are done with this. Let's tick. Okay. Given that the high rate of the plant is um 3,000 per day, determine the unit cost. Okay. Okay. So you are supposed to determine the unit cost. Okay. So let's go and find the unit cost. So we are now on I. So we are calculating for the unit cost. All right. So we said that our unit cost the other day, we learned that our unit cost is equal to total, if we can all remember, total cost over total quantity. Is that it? This is it over here. Let me change and use a different color pen. So this is our unit cost. The formula for it, our unit cost is equal to total cost over total quantity. Okay, so let's go. So our unit cost now, let's say our unit cost is equal to total cost over total quantity. So you see, so we can now go ahead and calculate for our unit cost as um, what is the value of our total cost? It means that we have to now go and find for our total cost because we don't know, but we know for the total quantity. The total quantity is 30,000. So you see what is happening over here. So this is a question mark because it's unknown. This is unknown. Okay. All right. So we now have to come and find for our total cost. But we say our total cost is equal to duration times high rate. right? Okay, so let's now come and find for our total cost. Let's now come and find for our total cost. So our total cost. So let's say BAT. Okay, our total cost. But our total cost is equal to duration times high rate. Or high rate or even daily rate. Okay. Mm, so this is it. So if you also wish to see it very well, this is the formula for the duration over here. Uh, Total cost, the formula for the total cost. So you see, the total cost is equal to duration times high rate or even daily wage in some cases. Okay, yes. So let's proceed. So we can now say that our total cost, TC, total cost is equal to, what did we get for the duration? 50. 50 days, 50 days times what? The high rate. And the high rate given was um 3,000. Okay, so it was 3,000. So let's go. So 50 times 3,000. And what are we going to get? At the end of the day, our total cost is going to be equal to, let's all punch it together, 50 times 3,000. This is a practical cost. If we are doing something and you don't participate, uh, you are going to think you understand, but at the end of the day, in reality, you may not have understood. Okay, so practical is always the best thing to do. Okay, so have a look. Since our money is in Ghana cedis, it means that we can write our final answer in Ghana cedis. So take note that total cost, this is cost we are writing. Okay, so after the calculation, we are going to get 150,000. Okay, 150,000. So you remember to add, it is money, you have to write it. Add it 0.00. Okay, just as it is over here, you can see I've added all the units for you. All right. So now we are done calculating for our total cost. So we can move back to our unit cost and uh, solve the work. Okay. Okay. So our unit cost now, we can say that. So now our unit cost, now our unit cost or TC can be said to be equal to 150,000. Okay. All over the total. quantity. Okay, which total quantity are we using? We are using the what? 30,000 meters squared. Thank you. So 30,000 meters squared. So you see how our answer is going to be. So finally, we can say that our unit cost, okay, can say that our unit cost is equal to, let's do some calculations over here. Let's all do that together. One, two, three, four. So four zeros, or let's do it bit by bit. These three zeros can take care of these three zeros, and then this zero can also take care of this zero. 3 will go into 15 how many times? 5 times. So you see, so our unit cost is 5. Okay, so our answer is going to be THS 5.00 per meter hot squared. That is all. Now you bring the point zero zero that is over here. Okay. Mm-hmm. 0.00 exactly per meter squared. You see, now you are done calculating for your unit cost. Uh-huh. So we have to move to our next SAP calculation and look at the next thing we are supposed to calculate for. So in this case, um, now we are done with this one. So let's take, okay, so we are supposed to come and now solve for um, IV. So IV says that if the height, let me enlarge this a little bit. If the height of hoarding is 3 meters, determine the area of the hoarding. So assuming that the plot is a square plot, okay, so we are supposed to now determine the area of hoarding, assuming that the area is a square plot. Okay. Okay, so how do we even know the length? Okay, because now we only know just the area. Okay, if you have a square like this, okay, good. Now you know that here is L. Since it's a square, everywhere is all sides are equal. So length, 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 length. And now they are saying that the area is equal to 30,000. So you can just write 30K. I believe we all understand. Okay, meter squared. So you see what is happening over here. So now how do we get the value of the L? How do we get the value of the L? How do we get the value of the L? Okay, good. But you also know that the area is equal to what? In this case, what is going to be the value of the area? The area is also equal to the length and the length in this case. Okay. Uh-huh. Otherwise, let me put it in this case for you to also see our area A is also equal to the what? The length times the length. So finally, you realize that our A is also equal to what? L squared. Okay, good. So in place of this, you can rewrite this as what? Your L squared is equal to 30 times 10 exponent 3 meters squared. At the end of the day, If you square both sides, you're going to get the value of your hot L. And that is what smart students will do. If you do that, you're going to get your value of your L to be 173.21 meters. You see. So you can quickly try that on your calculator and then we proceed all together. Okay, we proceed all together. I chose to leave my answer in just two decimal places. It's a choice. It's a choice. I actually had 173.2050808. Okay, but I just two decimal places. I round the five to the zero, making it to one. Yes, so let's proceed. Let's proceed. So this is now we are moving to our Ivy. Okay, good. So Ivy says that you're supposed to calculate for the area of the hoarding. Area of hoarding. So this is our area of hoarding. Okay. So our area of hoarding, as we all know, as we all know, area of hoarding is equal to perimeter times height. Okay. Yes. So the area of hoarding, area of hoarding is equal to the perimeter times height. You see. So our area of hoarding, if you see me writing this, is the same as area of hoarding. Don't get confused. Okay. So our perimeter, how do we get our perimeter? Now we already know the length. Okay. We calculated for the length some already. So I believe we already know the length. Yes. So our perimeter, if we are having, let's say, four sides over here, one, two, three, four, our perimeter is going to be equal to what? 4 times what? L. Okay. Our perimeter is 4L because if you have P is equal to L plus L plus L plus L, they all have a coefficient of 1. If you add them, you can just write 4L. That is all. So this is going to give us what? 4L times H. Okay, so this is the same as the 4 times what? L times H. Okay, so my area of hoarding is now equal to 4 times the length. And when we calculated for the length, what did we get? We had 173.205. We ran it to 21. So we had 173.21 meters. So let's write 173.21. Good. So you see as we are having over here times the height. And what is the height of the hoarding? Let's go back to the question. The height of the hoarding is 3 meters. You see, if the height of the hoarding is 3 meters, so we can now multiply it times the height meters. So times 3 meters. Okay, so at the end of the day, you realize that our area of hoarding is going to be equal to 4. 4 times 1, 4 times 173.21 times 3. At the end of the day, you realize that we're going to get 2078.52. Okay, yes. Since it is area we are calculating for, our answer is definitely going to be in what? Meter squared. Because perimeter is in meters, and this guy is also in what? Meters. You see. So we are definitely going to get answer in meter squared. Okay. So we are done calculating for our area of hoarding, and that plays a vital role in our calculation. So you have seen that the total quantity now have changed. Okay. Note, in this case, the total quantity is now at the area of hoarding we are going to be using. So our area of hoarding, take note when you meet this kind of questions. Now you have to know that your area of hoarding is the same as your what total quantity from here going. Okay, which is equal to what? 2078.52 meter squared. All right, so let's proceed. So now we are going to the next part of the question, which I believe is then I. Okay, so I'm going to clean all of this. I believe we have all taken a screenshot or written it already. If you haven't, you can reverse the video. Make sure you have that. Add it to your favorite on your phone so that the more you see it, life is going to become much more easier. Yes. Most of the questions you are seeing today, when you meet them in future, I hope and pray you'll be able to give an account just as I'm doing. All right. So we are done with this part. So we take. So we are now on what vein. If the carpentry gang, if the carpentry gang has an output of 1,000 meters squared per day, determine the duration. Okay, now we are supposed to determine the duration again of the carpentry gang. So if the carpentry gang has this output, okay, okay. So um let's move. So we are moving now. So this is now we are calculating for the duration. So the carpentry gang, the whole day they can work. The hoarding they are going to be doing, they can do it as a total area of 100 meters squared a day. Okay, Yeah, so let's say duration of carpentry gang. Okay. Yeah, so this is our duration of carpentry gang. Okay, so carpentry gang, you see their duration. I believe we have all seen it. Okay, so it's still the same formula we are going to be using. Okay, so just as we all know, our duration is equal to the total quantity over the daily output. Okay, yes, so total quantity all over the daily output. Okay, so now we can say that our duration is equal to which total quantity are we going to be using? Now is this one. You see, so that is the uh, total quantity of the area of holding that they are going to be doing. Okay, now we are done. We are holding now. Okay, so you have to make your focus come to here. Anytime you are done calculating for the area of holding pair, you have to know that the total quantity have now changed. Okay, yes. So that is the total quantity for the area of holding, and then we have to maintain that value over here, 207.8.52. So that is it. 207.8.52, you see, meters squared all over the daily output. And the daily output of the carpentry gang is 100 meters squared per day. You see. So this is 100 meter squared per day. Good. From here, what have you realized? You see that meter squared can take care of meter squared. And what are we left with? This 100. It can also shift this to here and shift this to here. So our duration is going to be 20.7852. You see, yes. So let's write our new duration. And our new duration now is going to be, um, so our duration now is equal to 20.785 to um day. Okay, days. Yes, days. Okay, so at the end of the day, how can we finalize our duration to be? We can just say our duration is duration has to be written as a whole number. Okay, so finally we can say that therefore our duration is equal to 21 days. See? So that is our duration. That is our duration for the carpentry gang. Okay. So let's move to our next question. And now we are done with this V. So VI. If the carpentry gang comprises three carpenters, good, three labors, determine the cost of labor used in erecting the formwork. So they want to know the cost of labor used in erecting the formwork. So let's quickly go about that. Let's quickly go about that. We are now on VI. So this now becomes our VI. So the VI says that we have to calculate for let's say cost of labor. The total cost of labor. So it should be the total cost rather. The total cost of labor. So the total cost of labor, um, um, we all know that total cost is equal to duration times high rate, right? So let's quickly proceed. The total cost now is equal to the duration times the high rate. You see. So the total cost, let's all write that together. That's the total cost is equal to duration times high rate. So you can now say that our total cost is equal to the duration we had is 21 days. So you're going to say 21 times the high rate. And our high rate uh, over here uh, is unknown. Okay. Our high rate over here is unknown. Our high rate over here is unknown. So we have to put question mark over here. And now we have to go and calculate for the high rate. You see, we have to now go and calculate for the high rate. So we are going to say that our high rate is equal to um, let's say uh, um, since there are two, let's say three carpenters. Watch oh, since there are three carpenters and three laborers, because they said three carpenters and three laborers. Okay, so since there are three carpenters and also three laborers, so uh, that is how we are going to know the total. Uh, that's how we can know the high rate. Okay, that's how we can be able to know the total high rate. So this is the total high rate. This is the total high rate. Okay. So let me edit here too. Well, let me write this as the total high rate. The total high rate. Okay. So um this one I didn't specify because it's the total hire rate. It's normally varies. Okay. So in this case, let's say that if the carpenter is going to be taking let's say 200 cities. Okay. Let's say that the carpenter will be taking 200 cities. Today, in today's world, let's say that the carpenter is taking um 200 cities, 200 cities for carpenter per day. And then the labor also takes, let's say, 150 Ghana cities, okay, per each labor. So this is 150 Ghana cities, okay. So at the end of the day, you realize that if you put here is going, this person takes 200 for carpenter and 150 for the labor. Okay, so at the end of the day, our total high rate, our total high rate is going to now become um let's all point this together. This is going to become 600 plus 450. Okay, so finally you realize that our total high rate, total high rate per gang day, okay, is going to be equal to um 1050 cities. Okay, 1050 cities. So this is as I'm writing over here. So now we can go and set our total high rate and the total cost, and then we are good to go. Okay, so let's quickly do that. Let's quickly do that. Let's proceed. So we said that our total cost, so our total cost was equal to um, duration times total high rate. Okay, so let's quickly repeat that formula before we continue. Our duration times the total high rate. Okay, so now our total cost, we say the duration is equal to 21 days times the total high rate that we had, um, 1050 cities. So at the end of the day, our total cost is going to become, let's say, our total cost, okay, our total cost per gang day is going to become, um, um, 22050, okay, 0.0 0. So our total cost is going to be 22,050 cities. Okay, Ghana cities. Okay, yes, for erecting all the hoarding. Okay, all the hoarding work. So let's proceed. Um, so let's proceed. So the form work, that is the money that will be required. 22,050 cities will be required in erecting the form work. So we are done with this one. So let's proceed with the VII2. Okay. So this one say determine the Wawa board required to erect the form work. So this is talking about numbers. Okay. Determine the number of Wawa board required. Determine the number of Wawa board required. So we are on a different section now. We are on VII. So this become our VII. So this is the number of Wawa board required. So this is the number of Wawa board required. You see. So the number of Wawa board required. What is the formula for calculating for that? I'll show you now. This is it. Number of Wawa board required. If you want to calculate for it, this is the formula you can use to calculate for your number of Wawa board required. And it's equal to the area of hoarding over the area of a Wawa board. The area of a Wawa board is, this is the value for, I've provided you the value is 0.3 meters times 4.2. Okay, good. So you have to know this. Let's proceed. So the number of Wawa board required, this is it. Our number of Wawa board required, number of Wawa board required is equal to area of hoarding, the area of hoarding all over what? Area of Wawa board. So I've already showed you the formula, and that is 0.3 meters times, let's say 4.2 meters. Okay, so let's just key in the values, and then let's see how best we can be able to travel. So this is 0.3 meters times 4.2. If you take a wire board, our own wire board that we have been using, yes, if you take that wire board, this side is equivalent to what? 1 foot. It's equivalent to 1 foot, and 1 foot is equal to what? Yes, 1 foot is equal to what? And this side. So at the end of the day, here we count the 0.3 meters, and here is what? 4.2. That's our board we have been seeing. So don't get confused. Okay. Yes, so let me clean it quick, and we proceed. Okay. So the total quantity we are using, you already know, that is 207. Okay. So this is it over here. This is the total quantity we are using. 207.52. 207.8.52. This is it. This is the one we are using. So we are going 207.8.52. This is 2078.52. Okay. Meter squared. So at the end of the day, this is going to become, at the end of the day, let's all point this together. 2078.52 all over 0.3 times 4.2. And you realize that we're going to get 1649.6. It continues like that. Okay. So we are going to get 1649.6 190 whatever. Okay, but this at the end of the day we have to run it. Okay, so this is going to become 2. Okay, so that's the number of hour board required. But you realize that let me just represent here by n and don't get confused. Okay, since we want it in numbers, so the number of hour board required, this we have to add what 10% wastage. Okay, so let's add 10% wastage. Anytime you do this, always remember to add the 10% wastage. So we also add, okay, 10% waste. Okay, okay, so 10% of this. So let's say 10% of this value. Okay, times 1649.62. Okay, so let's all do that together. 10% times 1 point, or let's say not point 1649.62. Whereas that you are going to get an answer of 167.962. Okay, so at the end of the day, we are saying let's add 10% wastage. So let's add 10% wastage. So that is the 10% waste we are doing. So uh, the 10% waste, now we are going to add it to it. Okay, and we are going to add it to it. So at the end of the day, we are going to add this value to the end. So what are we going to do? Let's put this over here plus the n. Okay. And so at the end of the day, this is going to give us 1667 point 962 plus the value we had, and this was 1649.62. 1649.62. Okay, so at the end of the day, let's all add this together. Let's all add this together. 167.962 plus 1649.62. So at the end of the day, what are we going to get? You realize that we are all going to get um the number required. We're all going to get 1817. This is 1817.58. Okay, yeah, so after adding the 10%, and this was the 10% wastage, 10% waste after adding it to our number that we had initially. So if I write here to be NI, you should know that that is the initial number we had. So the initial number we had 1649.62. This is 1649.62. So at the end of the day, we added the waste percentage to it. That is 167.962 plus 1649.62. At the end of the day, we had 1817.582. Okay, so that is the number required. That is the number required. So we can now say that our number required. So number of our board required. Okay, number of our board required. So finally, our number of our board. Our number of our board required is equal to so let's run this to the whole number 1816. Okay, so that is it. 1816. Okay, our board. So that is the number they are going to be buying. Okay. So we are done with this one too. So this one they say we should now determine the principal quantities. Determine the principal quantities. How do we determine the principal quantities? So that is our VIII. So this is now our VIII. So principal quantities. So these are principal quantities. All right. So our principal quantities, take a clear look at some of these things I've put over here for you. Okay. For the principal quantities, you see these are the principal quantities. Your area to be cleared is should always be in meters squared. Because they said area, they didn't said volume. Area, area to be excavated, meter squared. The word is area. Area to be compacted, meter squared. When you hear volume, you can say it is meter cube. Area of holding, as you know, it is what? Meter squared. So that is it. These are some basic tips you should know. So let's go and list our principal quantities. Okay, okay. So let's go and list our principal quantities. So I our so let's start area to be cleared. So this is our area to be cleared. Okay, and I is going to be what? Area to be excavated. Because after the clearing, they're going to do excavation. Area to be excavated. So this become our I, I, and that is area to be compacted. Area to be compacted. Okay, and then the IV now going to become volume of excavation. Then we are coming to the veins, the area of holding. Area of holding. Area of holding. So let's key in the values and then let's go. Area to be cleared. Our area to be cleared, that is the area of the plot they are talking about. Oh. Area of the plot they are talking about. So the 3 hectares. This is the look at if you come to the main question. This is the question is take notes. A plot of size 3 hectares is to be cleared, excavated, compacted, and then ordered. So these are the principal quantities. Okay, so let's move to our solution and see how best we can be able to travel. Okay, so the area to be cleared is what? 30,000. 30,000 meters squared. And then area to be excavated is also what? 30,000 meters squared. It's the same area they will excavate, the area they will clear, is the area they will excavate. Meter squared. Area to be compacted, that is the surface treatment, is still the same thing. Or even the earthwork support, some people may call it at times. They are all the same thing. Okay. But when we talk about the volume of excavation, things change. Look at the volume of excavation. The volume of excavation is what we calculated for over here. That is the 7,500. Okay. Yes. So 7,500 7,500. This is in meter cube. Meter cube. Okay, and then the area of hoarding, as we all know, area of hoarding, as we all know, area of hoarding, the area of hoarding we calculated for over here. What did we had? 2078.52. 2078.52. So let's quickly key in that. So that is 2078.52. Okay, since it is area they are talking about, our unit is supposed to be in meters squared. Good. We are done with the principal quantities. Okay, so these are principal quantities. We are done listing them. We can tick here. Now let's come to our IX. If the contractor added 30% for profit and overloads, determine determine the unit rate and hence deduce the level of profit. Okay, so if the contractor added 30% for profit and overload, determine the unit rate. That is two questions they're asking you in this state, and hence deduce the level of profit. So this is two troubles, two troubles they're trying to give us in just one question. Okay, so let's quickly solve it together quickly, and then uh, I'm planning to make this video very short so that it can be easy to watch. And then in the next question, in my next video, I'm going to take time to talk more about depreciation. Yes, I'm going to take time to solve more questions on depreciation. Yes, if possible, if we can also solve like one of these questions in addition, why not? All right, all right, all right, all right. So we are supposed to, first of all, we are supposed to calculate for our unit rate. Okay, so this is unit rate. So the unit rate. So the unit rate, look at the formula for the unit rate. This is it over here. You see the unit rate? The unit rate is equal to the unit cost plus X% times the unit cost itself. Okay, so, and if I'm saying that, it means that our unit rate, our unit rate is equal to the unit cost. Okay, the unit cost. Okay, yes. The unit cost plus the percentage, okay, times the unit cost itself again. Okay, okay, plus the bracket open. So let's say uh, X% times the unit cost itself again. Okay, now I can close the bracket. So now I can just move quick, and we go. Okay, so this is my unit rate. So my unit rate is equal to what? The unit cost. And the unit cost, which unit cost are we talking about or are we referring to in this case? Let's go back to the question. The question says that if the contractor added 30% for profit and overloads, determine the unit rate and hence deduce the level of profit. Also, if the contractor wants to finish the clearance in 5 days, what are his options? Okay, okay. So this implies that the unit cost we are supposed to use is the one we calculated for initially. Okay, uh-huh. Is the one we calculated for initially. So let's go and take our unit cost. What is our unit cost we calculated for? We had 5.00. So this is it. We had 5.00. Okay. So that is what we use to solve our work. So this is 5.00. Okay. Plus, what is the percentage they give in the question? They said 30%. So in this case, our x is for 30%. So 30%, 30%, okay, 30% times the unit cost again, 5.00. You can quickly point this and you realize that life is going to become much more easier. Okay, you can quickly point this and you realize that life is going to become so 5.00 plus 30%. If you press shift and brackets open, you see the percentage sign. Okay. Times 5.00. At the end of the day, you close your bracket. So you're going to get 6.5. Okay. So at the end of the day, your unit rate is equal to 6.5. So this is it. 6.50. Okay. Yes. Per meter squared. Okay. Per meter squared. Okay, because our unit cost is in per meter squared. Okay. So we are done calculating for the unit rate, and that's still the same question. We are supposed to find for the hot. This is it. So this is question one. And this is also another question. They say deduce the level of profit. So level of profit. Let's also calculate that quick. And then we proceed. So we have to now calculate for our level of profit. So the level of profit, take note that your profit is equal to, the formula is here. You see, take note, your profit is equal to amount received minus the total cost. Okay, so let's write the formula together. So our profit in this case is equal to what? The amount received minus the total cost. Okay, just as we are seeing over here. So let's proceed. But you realize that at the end of the day, if you want to repeat this, you realize that one is known and one is unknown. Okay. So at the end of the day, our profit is equal to this one we don't know minus the total cost. For the total cost, we know that it is equal to what? We calculated for it together. Yes. So that was 150,000, I guess. I'll show you shortly so that we can proceed. So this is it. We calculated for it over here. Okay, the total cost, this is it. 150,000. Okay, what we calculated for. So I believe we can now proceed. So now we have to find for the amount received. Okay, we have to find for the amount received. And the amount received, so you realize that it has become a problem. So we have to find for it. Okay, but you have to know that your amount received, okay, your amount received is equal to total quantity times the unit weight. Okay, is equal to the total quantity times unit rate. So what does that imply? We just have to key in the values and then we are good to go. Okay. Mhm. So I feel like using a different color pen to make this a bit dynamic. So our amount received, our amount received, the amount received is equal to our total quantity, which is 30,000. One, two, three. Okay. Times the unit rate. The unit rate, what did we get? 6.50. So that is 6.50. Okay. At the end of the day, what are we going to get? Let's all multiply this together. Let's all multiply this together. And 30,000 times 6.50. We're going to get 195,000. We're going to get 195,000. Okay. That is your amount received. So I'm going to clean this and rewrite it well before I use it in my further calculation. So um, this is it. That is 195112.000. Okay. So that is it. And then at the end of the day, at the end of the day, we are done with our amount received. Okay, so we can now go on to calculate for our profit. Okay. Uh-huh. So we can now go, since we know our amount, we can go on to calculate for our profit. So we say our profit is equal to amount received minus total cost. This is the formula for the amount received. Some people are worried. This is the formula for the amount received too. Okay, yes. That is 7. You see it. If you are worried, I can clean all of this so that at least it can become free. So the amount received, that is it. You are seeing over there. That is it. You are seeing over there. The amount received. This is the amount received. Exactly. So our profit, we can continue from there. Since we said that our profit is equal to, what did you say? Our profit is amount received minus the total cost. We said amount received minus total cost. Okay. Okay. So uh, okay. So let's continue. So we can now say that our profit is equal to 195,000. 195,000. Okay, minus the total cost. And then the total cost was what? 150,000, if you could remember very well. 150,000. So at the end of the day, the profit is equal to, let's do that together. 195,000 minus 150,000. You're going to get uh 195,000 minus 150,000. We're going to get 45,000. Okay. So that is going to become 45,000. Okay. So this is going to become uh 45,000. Okay. That is the profit. So what are we supposed to do next? What are we supposed to do next? Let's go to the question. So we are done with this one too. Okay. So we are done with this one. So we are now on this. If the contractor wants to finish the clearance in 5 days, what are his options? Discuss. Okay. Yes. So for the X, this is how to go about the X, and then this is how to go about the X. I want to solve that on a fresh page. So I'm going to take a fresh page quickly, and then in my lecture 3, I'm going to be focusing mainly on depreciation. Yes. So this is the X, and then uh, the X. If the contractor wants to finish the clearance in 5 days, what are his options? Okay. So let's put it over here. His options. His options. His options. Okay. So quickly, uh, we are going to say that we are going to start from here. Okay. So our new output, new output is equal to the total quantity over the duration. Okay. The total quantity over the duration. Okay. So let's quickly calculate for our new output. So our new output can now be said to be equal to the total quantity 33 acres, which you say is equal to 30,000. 30,000. 1, 2, 3. A physicist will say 30 kilo. Yes. So let's proceed over the duration 21. No, 5 days. Okay, look at this. They said that if the contractor wants to finish the clearance in 5 days, so a new duration has been specified over here. What are his options? Okay, so 5 days. So this is meter squared. 5 days. Let me highlight that for people who are still wondering. This is it. 5 days. Yes. So that is it. At the end of the day, our new output is going to be equal to, if you divide this, you're going to get 60,000. Okay. You're going to get, let me say 6,000 rather. 6,000 meters squared per day. So if you divide 30,000 by 5, you're going to get 6,000, okay, meters squared per day. So that is our new output. Okay. So at the end of the day, since we are getting our new output to be 6,000 meters squared per day, it implies that our number of plants, watch, our number of plants, our number of plants Our number of plants is equal to what? New output over the old output. Okay, that is the new output. New output is not part of the formula, so make sure to write it. These are some of the advantages of watching the video to the end. New output over the old output. Old output. Okay, so this is it. So at the end of the day, what are we supposed to do next? That implies that our number of plants, our number of plants our number of plants is now going to be equal to which one was our new output? Our new output we just calculated for is 6,000. Okay, two, three, 6,000 meters squared per day. And then our old output, it is in the question, you will see it. This is our old output, 600 meters squared per day. So let's come and divide 600 meters squared per day. 600 meters squared per day. So you see what we are all seeing over here. So at the end of the day, if this cancel this, these two people will cancel this. Two zeros will take care of two zeros. Six will go into itself one time and go here how many times? 10 times. So you see, we are going to get what? The number of plants is going to be 10. Okay, so finally we can say that our number of plants is equal to 10. So we can say that therefore the number of plants, therefore the number of plants is equal to 10. 10 plants. You see, the number of plants is equal to 10. So you have 10 plants. Okay. So therefore, he has to use a single plant with an output of, let me say, 6,000 meters squared, or use 10 plants with an output of 10 meters squared per day. Yes, so I wish I could type this over here. Okay, so let me change the font size. Okay, this is okay. He must use a single plant. Okay, with an output of 600 meters squared per day. Don't worry, I'll fix the meter squared there later. Or use 10 plants each with an output of 600. So per day. So the first one I think is supposed to be 6,000. Okay. So he must use a single plant with an output of 6,000 meters squared per day. So this is how to type that, and that is meter. Um, oh, I don't have this symbol over here. Okay. So, and then this is also okay. So I want to just fix that. Well, so this is my conclusion. Okay. This is my conclusion. Okay. So that is it. That is it. I want to add a unit. This is meter squared. Yes, and this is also meter squared per day. Okay. So let's say he must use a single plant with an output of 600 meters squared per day, or use 10 plants each with an output of 600 meters squared per day. Okay. Yes. So the question was that um, if the contractor want to finish the clearance in 5 days, what are his options? Discuss. Okay. So now we've done our calculation. We have seen that if he wants to use, let me say, a single plant, it means that he's going to need a plant with an output of, let's say, 6,000 meters squared per day. Oh. Okay. Or if you want to use 10 plants, then it means that uh, each of the plants can have 600 meters squared per day. Okay. So this is how far we have become. Don't forget to meet me in groups, in person, one on one, in case you encounter any challenges, or there is anything you don't understand, or you even wish to understand better. Yes, or maybe you wish to understand better. So this is how far we have come. As you can see, um, this is how far we have come. So I want us to also look at uh, the depreciation. Okay, I want us to also look at depreciation. So this is a question I have on depreciation over here, and the question says that a company bought a plant at 60,000 and later sold it at, let me say, this is an error. It's supposed to be, and later sold it at um, 20,000. Okay. Uh-huh. 20,000. Because I also have the question over here. I have that question, same question over here. Okay. Okay. Here it says 10,000. Okay, then let's adopt that. So, um, let's say this is 10,000. So this is 10,000. Okay. So let's say this is 10,000. Mm-hmm. Let's say this is 10,000. Yes. So let's proceed. We are just going to start from our given and see how best we can be able to travel. Okay. So this is our given. So this is our given. Okay. Mhm. So a company bought a plant. A company bought a plant at 60,000 and later sold it at 10,000 after 5 years. Determine the various types of depreciation given that the annual working life is 100 years. Good. Look at this. Are the various types of depreciations we have. Okay. In some cases, if they don't say types, they will say forms. So let me say types or forms of depreciation. Types or forms of depreciation. Types or forms of depreciation. Forms of depreciation. Okay, so this is it. So you will be seeing how we'll be applying them now to solve our questions. Okay, so let's quickly proceed. So this is our given. Okay, let's not waste more time at all. This is our given. This is our given. Okay, good, good. And a given, a company bought a plant at 60,000. Yes, a company bought a plant at 60,000. So the 60,000 you are seeing, I want to ask a question. Do you think that is going to become our initial resale or uh, final resale value? Okay. So the initial price, or let me say the initial cost was what? So this is the initial cost. So the initial cost, the initial cost is equal to, let's say, 60,000. Okay, good. And then the resale value, the resale value is equal to the person went to sell the thing again at the company at, let's say, 10,000. Okay, good, good. And at the end of the day, the company bought a plant at 60,000 and later sold it at 10,000 after what? 5 years. So lifespan, let's write lifespan. So lifespan, so the lifespan is equal to 5 years. And then what else again? Determine the various types of depreciation, given that the annual working life of the plant is 2,400 hours. Okay, so the annual working life of the plant in the whole of 1 year, it works for 2,400 hours. So let's say the annual working life. So this is the annual working life. or in some cases, they can also call it effective working life. Okay, so don't get confused. So the annual working life is equal to 2000, 2400, as you are seeing over here. Our given is not supposed to be here. That was nearly a mistake I did. So this is just supposed to be, what's this? So this is 2400 hours. Okay. Mhm. So let's write 2400 hours. Good. So let's go. So this is hours. Okay. So we can now proceed or continue from our solution. So this is solution. Solution. Okay. So the question says that we should determine the various forms of depreciation. So determine the various types of depreciation. And the various types of depreciation, that we have the daily depreciation. These are them over here. Look at, we have the daily depreciation, hourly depreciation, weekly depreciation, monthly and a whole lot. Okay. But you should know that before you can even calculate for the daily depreciation, you have to know the what? Annual depreciation. Without the total depreciation, you can't calculate for the annual depreciation too. Okay. So let's just take time and calculate all the types and forms of depreciation, and then we are good to go. Okay. So first of all, we have to know our total depreciation. Okay. Okay. So this is our question two we are solving. So let me put over here. So let's just proceed. So our total depreciation. So this is our total depreciation. Total depreciation. And the total depreciation is equal to, look at the formula. What is the formula for the total depreciation? Initial cost minus resale value. Okay, good. And what is our initial cost over here? Our initial cost is 60,000 and our resale value is for 10,000. So let's do that together. So our initial cost, okay, let's put down the formula. Initial cost minus resale value. Okay. So this one we are doing over here is the total depreciation. Okay. Yes. So first of all, we are working on the total depreciation. Total depreciation. So that's the total depreciation we are done with. So after the total depreciation, we have to come and calculate for the annual depreciation. You see. Mhm. No, but we are not done yet with the total depreciation. Okay. So when we are done, we'll come to the. So the total depreciation now is equal to what? 60,000 minus the resale value. And the resale value is 10,000. Okay, so what is going to be our total depreciation then? It's just going to be 50,000. Okay, so that is going to become 50,000. Let's all point that together. 60,000 minus 10,000. You see, at the end of it, you're going to be left with a 50,000. Okay, so that is our total depreciation. So now we can come and calculate for our annual depreciation. Okay, so annual depreciation. Okay, and our annual depreciation is equal to the total depreciation over the number of years. Okay, as you are seeing over here. So our annual depreciation, let's put down the formula. The annual depreciation is equal to the total depreciation over the number of years. So this is the total depreciation. So that is the total depreciation. So our annual depreciation now can be said to be our annual depreciation now can be said to be equal to uh, the number of years was 5 years, and the total depreciation we had was what? 50,000. Okay, so let's put it over here. 50,000. Good. 50,000. So you see, if we divide 50,000 by 5, 50, 50,000 divided by 5, we are going to get, let's say 10,000. Okay, we're going to get 10,000. So our annual depreciation is equal to 10,000 per years. Okay, this is in years, 5 years. Okay. So at the end of the day, our annual depreciation is equal to, or annual depreciation is equal to, let's say 10,000 Ghana cedis every year. BL they depreciate by 10,000 Ghana cedis. Okay, 10,000 Ghana cedis per year. But I'm supposed to bring point zero zero first. Point zero zero per year. Okay, that is the annual depreciation. So from the annual depreciation, what are we supposed to do next? The next thing we're supposed to do now is that now we can now move to our what? Daily depreciation. Okay, good. So our daily depreciation, just as we did over here, our daily depreciation. This is it. Daily depreciation. Daily depreciation. And our daily depreciation, our daily depreciation is equal to annual depreciation over the effective working life. Okay, so that is the annual depreciation. The annual depreciation. Depreciation came in last year's question, so please take it serious. Okay, annual depreciation all over the what effective working life. Okay, all over the effective working life. So the effective working life. Okay, so now we can accelerate. Okay, so my daily depreciation now is equal to um but take note, we want the answer in days, so but the effective working life was given in what? Let's say hours. Okay, that was 1,200 and what? No, it was 1,200 hours. Okay, let's go and review and see. It was 2,400 hours rather. So let's say 2,400 hours. Okay. All over the and the annual depreciation, we had 10,000 per year. Okay. That is the 10,000. Okay. But since we want the answer in days, because we are dealing with daily depreciation, we have to convert the effective working life to 24 hours. Okay. So to convert it, we have to just, how many days do we have in, let me do that convention. How many days or how many hours make one day? Okay. So look at that calculation over here. So that calculation implies that what? If, watch, if what? 1 day is equal to 24 hours, then it means that x is equal to what? 2,400 hours. Okay. So now what do we do? We have to just do cross multiplication. Okay. So after the cross multiplication, you realize that your x is going to be equal to what? 2,400 over 2,400 all hours all over what? 24 all over what? 24 hours all over 24 hours. Remember, this guy is in day. Okay, so per day. Okay, so at the end of the day, you see what you're going to get. If this guy take care of this guy, you realize that you're going to this 24 will go here how many times? So you're going to get 100 days. Okay, so 100 days. So x is going to be equal to 100 days. Good. So let's quickly go and I'm done doing this convention. I did it on a different page, just that I didn't put it on this page. So you have to jot down something. If you were writing down something, you would have had it in your book at least. So this becomes what? 100 days. Because it's a newcomer, let me use a different color pen. No, you let's forget. 100. So this becomes 100. Okay. Okay. To be on a more safer side, to be on a more safer side, let me do it this way. And that is 2,400 hours. Okay. Uh-huh. But, but, but what is happening? But what? 2,400 hours is equal to 100 days. Samayade. Okay. So at the end of the day, our hot daily depreciation can be said to be equal to 100, let me say 10,000, 10,000, 10,000 over 100, 10,000 over 100. All right. So this becomes 10,000 over 100. All over 100. Good. Good. Please don't forget to subscribe to my YouTube channel. Don't forget to like the videos. Don't forget to share. And don't also forget to comment. Yes, your comment is really needed, as that is what is going to enhance my level of creativity. If you don't give comments, I'm not going to know whether you are facing some challenges or not. Okay, so you have to give comments so that I know whether we're on the safer side or we're on a good side. So you have to like the video, you have to comment, and you also have to subscribe so that anytime I release a video, you'll be given a notification. Okay, all right, thank you. So 10,000 over the 100 uh days. Okay, now we have converted this one to days. Okay, good. So at the end of the day, you know that this one is in money. So at the end of the day, our daily depreciation is going to be equal to, so if two zeros take off two zeros, what are we going to be left with? We're going to be left with just 100 days, you see. Mhm. So the laws of estimation are the same for all observers in uniform motion relative to one another. All right. So we are done calculating for our daily depreciation. Sorry, this is supposed to be in a form of since uh, it's supposed to be 0.00 per day. Okay, 0.00 per day. Yes, I think the stress is too much. 0.00 per day. Here too, I made a mistake over here. Okay, so this is equal to this. Okay, okay. So this is the answer for our daily depreciation. Okay, yes, per day. Okay, so now let's come and calculate for uh, what next? Let's calculate for our hourly depreciation too. So let's calculate for our hourly depreciation. We are almost moving. We are going to soon be done. So this is our hourly depreciation. So this is hourly depreciation. Hourly depreciation. Hourly depreciation. So the hourly depreciation. We said that the hourly depreciation, look at the formula. Hourly depreciation is equal to the daily depreciation over 8 hours. Okay. So hourly depreciation is equal to what? So our hourly depreciation. So our hourly depreciation. So our hourly depreciation is equal to the daily depreciation over the 8 hours. Daily depreciation over the 8 hours. So our hourly depreciation, let's move. So now we are saying that our hourly depreciation can now be equal to, for the daily depreciation, we had 100. Okay, yes, over the 8 hours. So what is that going to imply? So that means that our hourly depreciation is now going to be equal to 100 divided by 8. Let's all do that together. We're going to get 12.5. Okay, so we're going to get 12.5, 12.5. Okay, so let's put it in the right order. So this is how our answer should be written. So 12.50, okay, per hour. Okay. So we are done with the hourly depreciation. So it's left with our weekly depreciation. Then from our weekly depreciation, we can now go to our monthly depreciation. Then we are done for the day. Okay. So now let's go to our weekly depreciation. So this is the weekly depreciation. Weekly depreciation. Good. The weekly depreciation is just equivalent to, because the whole of the week, the only active days you work, like you have 7 days in the week, you only work from Monday to Friday. So the only active working days are five. Okay. So the five times Monday to Friday is 5 days. So the five times your daily depreciation, that is all. So we say that your weekly depreciation, your weekly depreciation is equal to 5 times daily depreciation. Okay. 5 times daily depreciation. Okay. So finally, we can say that our weekly depreciation can be said to be equal to 5 times, and the daily depreciation. How much did we get? We had 100, right? So 5 times 100, and that is now going to give us our weekly depreciation to be equal to 500. Okay. So that is 500.00 per day. Okay. Okay. So that is our per week or per week or per week per week. So let me clean or and rewrite it all. So that is going to become 500.00 per week. Okay. So we are done with that one. We are done with that one. We are done with that one. So let's also check for our monthly depreciation. So monthly depreciation. So the monthly depreciation, or monthly depreciation can now be said to be equal to um, our monthly depreciation can now be said to be equal to, first of all, let me take this off. Now, this can also be equal to just, we have how many weeks do you have in a month? 4 times weekly depreciation. You can also do that. Okay. If you don't like that, you can go by uh, this effective working lifetime, the daily depreciation. Okay. Uh, so let's just use the first approach. That is the 4 times weekly depreciation. Yes, so 4 times weekly depreciation. 4 times weekly depreciation. Weekly depreciation. Okay, so that is 4 times weekly depreciation. So finally, we can say that our monthly depreciation. So all of this is the same as the monthly depreciation. Don't get confused. Okay, so our 4 times the weekly depreciation. The weekly depreciation, what did we get? We had what, 500? So 4 times 500, what are we going to get? You see. So therefore, we can say that our monthly depreciation is equal to 5420. So we can say that it's equal to what? Someone should quickly point that and just mention the answer and then let's proceed. Okay. Yes. So at the end of the day, 4 times 500, you're going to get what? 54 is 20. So 20. Now you can add the two zeros. 1, 2. Okay. So at the end of the day, we are getting 2000. But we don't want our answer to be like this. So this is the professional way. So we can now write 2000 points the per month. Okay, so that is how far we have come. We thank God for how far He has brought us. Um, Thank you all for this initiative also. But I wish we could put in much more and much more effort. For construction estimation, maybe you may write medicine, maybe you may not write medicine, but it is very dangerous. Okay, because if you had written the medicine, at least you would have known the areas that are going to be coming in the exams. Now they say you're not going to write the medicine. It means that you don't even know what is coming. So my people, construction estimation is not as easy as we are thinking. It means that we have to learn extraordinarily. Okay, because you can't predict the question. Okay, it's unpredictable. Yes, so that will be my best advice for you guys. Try to watch the video, watch it over and over and over and over and over again to make sure that you are well learned before the paper. Also, don't forget to meet me in groups, in person, one-on-one, in case you encounter any challenges. I'll be there to help you. I'll be there to help you And then also, if you find any other questions similar to whatever we have solved that you wish to also ask more questions for you to be clarified, I'm going to do that for you. Take note that these are some lists, the formulas we are using. This is a list of them. Okay. So if you need screenshots of them or sending, I won't send them to you. If you didn't watch the video, it means that you didn't have access to the formulas. Okay. So that is it. Do also take screenshots of them, keep them very well. Take notes of some of these important things I'm telling you. Okay, and some of these things I'm giving you. Make good use of this opportunity to make the A once and for all. Yes, to make the A's once and for all. Yes. So on this note, my name still remain Engineer Megabyte. On this note, my name still remains Engineer Megabyte. Exactly. Um, don't forget to throw $1 on my name in case you find this video very, very attractive. Thank you very much all. May God bless you. Bye bye.